Hello friends, today I will discuss a new topic, that is types of addressing modes. That is how different addressing modes are used in a computer, different instructions. Based on that topics I will discuss today. Okay. So actually what happens whenever design computer architecture, there are a certain number of addressing modes are used. Okay. So those modes access some data from either register or memory. So different ways data address or data accessing their own address based on that different addressing modes. So different ways addressing modes can be defined, can be designed as per the computer architecture. Those part today I will discuss. Okay. So you see here are different data types or different types of addressing modes are available. Here you see I have already mentioned different addressing modes, like that is a implied or implicit addressing mode, stack addressing mode, immediate addressing mode, direct addressing mode, indirect addressing mode, register direct addressing mode, register indirect addressing mode, next relative addressing mode, indexed addressing mode, base register addressing mode, last is auto increment addressing mode and auto decrement addressing mode. So different addressing mode are used in computer architecture whenever that is data address and access for different access to use for different instructions, either data address access from memory or register, like this, or sometimes both. Then different address mode is required to define as per the requirement of a instruction. Okay. So now one by one I will discuss those part. There are different category of addressing modes. Okay. Now we see first addressing mode is implied or implicit addressing mode. Okay. Implied or implicit addressing mode. This addressing mode is a very easy addressing mode, because you see whenever I go through that implied or implicit, it is actually that is no data, means particularly means zero address or address itself, implied to itself. Okay. Implied or implicit addressing modes means it is implied to itself. And data address, there is no certain address of data, because whenever it is implied itself, automatically data can access. Normally it is used accumulator to access the data, or add something data with the accumulator itself. And sometimes data also use without address, means zero address. Normally zero address, whenever you use that address, use in stack concept or stack organized concept is there, where there is no certain address of data. Okay. Data will be changes when as per this address, but that is no fixed data for address. It is done through a pointer. That kind of things also that is used for, that is implicit or implied addressing mode. One example I can take you, you see, the here is instruction, some here is instruction, and it use some certain data. Whenever you use certain data, then how the data is used for implied address mode or implicit address mode, money itself it is used, no need to identify the certain address. Okay. Okay. So we can take any example for this. Either sometimes I told that is it is used data itself. Whenever I go through a certain operation, like a complement accumulator. Okay. Complement accumulator, like this, suppose we use complement accumulator, then that complement use the particular data itself. just to complement its own data. Okay, there is no other data is only data. What data will take it? It is itself just a complement. That kind of a example we can also use. Okay, another example you can write, that is a zero address. Zero address. Zero address normally we can use in stack. Okay, zero address used at stack. We have already discussed how zero address of data used in a stack. That kind of concept we have already discussed in one lecture. Also you can see how zero address instruction is generated. So those kind of example is under implied or implicit addressing mode. That means data itself that is a itself is defined. Okay, data is itself is defined. So you can tell as a that is a implied or implicit addressing mode. Next is stack addressing mode. Stack addressing mode is very easy because that is it just fetch the data from top of the stack. Okay, so there is no if you although the each data stored in certain address, but that is not fixed. That data also whenever operated, then that address or that operand data also change. Okay, and again another data will insert, that is a push or pop operation whenever used for the stack, then address same address different data are used. So that the data having certain address not fixed. So that kind of operation used in a stack addressing mode. Suppose you see that here is the opcode part and operand part is there. In this case what happens, whenever you use this opcode part operand part, very simple way we can also define that how operand part and opcode part use in that particular stack operation mode. Okay, very simple way it is mentioned. Fetch stack the top of the stack, fetch from the top of the stack and perform action. Suppose we add something, addition of that is 3 and 4 7. Suppose for example you can write also add A and B. Okay, for example add A B, very simple, add A B means some data is there. Okay, some data is there, we just add that data from A and B. In that case what happens, suppose A is 7, A is 3, B is 7. In that case what happens, just add, just store the data A. So suppose first is 3, first is 7, second is 3, just add. When add operation will come, then top of the stack, that is add immediately 3 and 7. Here is 3 and 7. Okay, so immediately they will add. This is the basic concept regarding on the stack addressing mode. Okay, next is we can tell that is immediate addressing mode. Immediate addressing mode, it is a very simple way we can consider, that is immediate means immediate data. Okay, data not that is used, that is through certain operand. That means data is available is there, data availability is there. So we can also use immediate data, that is not go through certain that is operand. Data, direct data we can use, immediate data. Immediate data we can use. How immediate data use, I will show you, then you can understand very simple way. Here this is opcode and operand. This part, two part is there, opcode and operand. Operand data directly we can use. Very simple example we can take how operand data use immediately. You see, for example you can take, suppose add 10. Okay, add 10 means what? That means if add 10 and 10 value having some operand value. Okay, direct operand value we can add. That means what happens, if I see, since it is a single operand, use that is what accumulator. Accumulator store the data, accumulator plus 10. Okay, plus 10. Direct data we can use in this way. So immediate addressing mode means direct data value we can use directly. No use for or no use operand, and operand keeps some data. Not like this. This is the immediate addressing mode. Direct value we can use. Another is direct direct addressing mode. Direct addressing mode means where we use some operation for a direct addressing mode. Operand is available directly. So that is one reference is required to access the data from memory. That is only one reference is required. So a very simple way we can use this direct addressing mode. Here suppose all of you know that that is instruction having one part is opcode part, another part is that is a address part where data are available. This address is there, the operand direct go to operand access the data. So no problem, data is available in memory. Okay, in that case we can use a direct address. For a very basic simple example we can take it like SC. Okay, the instruction like very simple way, suppose add x for example, then what happens here SC is equal to SC plus x, and particularly this is that is a square braces used for a direct address because only one reference. Okay, this particular this kind of a symbol is known as one reference. We can tell as one reference. So direct address mode defined in this way. So if you add x, so SC plus x, in this way we can use. Okay, very simple example we can take it. So this is the basic concept regarding on direct address mode. Okay, now you see here is a that is another is that is indirect address mode. Okay, another is indirect address mode. If you go through indirect address mode, you see very simple way I will show you how the indirect address mode is defined. Okay, indirect address mode is defined in this way, very simple way. If you go through direct address, means address is used direct operand, then we can find out. But indirect address where that is address cannot find out the operand in a direct through direct address. So some effective address is there where operand can search where is operand. So one after one address they will search or pointer will search, then operand can find out. In this case based example we can take it same thing. If we go through the suppose add or that is same case we can also use add x. Similarly SC is defined plus x. You see previous case the direct case is a single reference, here is a double reference. Okay, two reference or double reference. So if we go through indirect address mode, we use a double reference or a two reference. In this way we can define that is indirect address mode. So you search the pointer search this address, effective address from here, effective address, then effective address search through operand. Suppose here another data is not there, again it will search like this one after one, it will search one that is a indirect address mode. Okay, so very simple one example also you can take here, no problem. I will show you. Suppose pointer searching some data different address, very simple way we can define. Okay, so here what happens, suppose here is 200. Okay, here is 200 is here. Okay, here is 300, here is 300, here is suppose 500. Okay, and these 500 come to 300, 300 come to 200, 200 here is the operand. Like this we can search it. Okay, so if you pointer here, then what happens, it will search where is the data. It now pointer is 500, 500 search 300, 300 search here, 300 having 200, 200 search where operand is available. So in this way different indirect address mode can be defined. Okay, so this is the basic concept regarding on indirect address, and the expression is defined in this way. SC is SC plus double reference of x, sum of double reference of x assigned to SC. So in this way we can define this indirect address mode. So next I will show you another address mode, like a register directory addressing mode. Okay, register directory addressing mode. Simple same thing. In actually direct address mode, indirect address mode, we use only memory. You see, I will show you whenever I go through direct address or indirect address. You see, we use memory. This memory we will use either direct address or indirect address. Okay, use memory. But if we go through register address, same concept, we use register only. Okay, where same concept, we use opcode register. So direct address operand is available, and this is the register where that operand can be kept in a register set. Different register set, the operand is available in a register set. So use, if we go through register direct address mode, so we use only register. Okay, and another is if we go through register, similarly no reference of memory is required because we use register only. So no reference is required here. Okay, CPU register, we use the CPU register. Actually register is a CPU register use. Okay, CPU register use, no memory is required. Similarly indirect address mode also same thing, we can also use register indirect address, same concept also we can use here. Register, go to effective address have a certain register set, again they will search operand which is available in memory. Okay, so this is the basic concept regarding direct and indirect address. Okay, so different concepts are there, I will show you. So similarly if we go through different operations of this direct register direct address or register indirect address, some similar concept also you can use, like suppose direct address here you can write address R. Okay, in this case what happens, same case we can write accumulator and loss R, since it is register are used. In this case what happens, similarly suppose add R, here you can write SC plus double square braces because it is a indirect address. Okay, since it is indirect address we can use in this way. Okay, now we see that is a other address, that is a relative addressing mode. Okay, next is a relative addressing mode. Relative addressing mode is a very important part because address is defined through a certain PC value. Okay, address is defined through certain PC value. PC is helped to find out the operand. Very simple way here is mentioned. That means if we go through this particular relative effective address, then what happens, we define the effective address in this way. Okay, we can define the effective address because with the help of a PC program counter the address can be defined. So effective address define value of a PC, because here we see PC, the value of PC plus and address of the instruction part. Okay, plus address of instruction. Okay, value of PC, because you add the value of PC, what is the value of PC plus address of instruction where data is available. So directly not go to there, some relative addresses mode addressing mode is there. So through PC it can be defined where is operand is available. Okay, that is the concept regarding on that is relative addressing modes. Very simple way, different addressing modes also can be defined. Okay, so because in PC is increasing, so automatically they find out where is operand. So this is the basic concept regarding on PC. Sorry, relative addressing mode. Next is indexed addressing mode. If we go through indexed addressing mode, same concept also we can apply, but simple another concept also there, using the register set and memory. Okay, using the register set and memory, because here what happens, whenever I go through that is index addressing mode, some index register is required. if we go through some index register, because normally previously what happens, address is defined and find out where is operand, but if we go through index addressing mode, so it is record the indexed register. So number of register set as record, again find out where is address, then it will search through index register or register set where is operand available. Operand is available in memory. Okay. So in this case, what happens? How to define that? That is address. That address is defined through. I will show you. That is effective address. Actually, this address is defined through effective address. So effective address also defined through base address. You see, base address which are available in a register. Okay, which are available in a register. Because go through register set, then find out the operand. So effective address is defined through base address and plus index register. Index register. Okay. What is the base address plus index register? Then find out here. Here base address here is mentioned. Again register index register mentioned. Both we just apply. Then we can find out that is a operand address which are available in a memory. Okay. So these are the basic concept regarding on that is a indexed address mode. So different ways we can also define, because operand field contains the starting base address in this case. Okay. Address of the array memory, because here you see array memory also use, and some array memory block and some register index register also we can use. Okay. Which contain the index value, and address base address. Okay. Base address plus index address will give the actually physical. This is the base address here plus index address is defined through register. So both combination of that to make that particularly index addressing mode. Okay. And actually physical address is defined through this base address where available in memory plus index address which are available in index register. Okay. Combination of that to make that indexed addressing mode. Next is similar case. This is the basic concept. Another also we can define that is a base register address. Okay. In this case, what happens? Previous case that is some register set we use. Here is a base register. Okay. Base register plus addressing mode. So this is the base register plus addressing mode is defined in this way, by which we can call as a base register addressing mode. Okay. So in this case, what happens? The effective address of operand can be found by adding, that is adding the value of the base register. Base register here we just add the value of base register, then we can define the effective address. So certain effective address can be defined through base register. Okay. With the part of the some instruction having some part address part, the base register, the address part is here, base register here. So identify the data in memory. Okay. And in that previous case what happens? So index address, here we define index address. Base address also define. Similar case must just use the base address. And multiple programs suppose reside in RAM, then we can use this base address mode. Okay. Because of different ways we can define. And when memory is full, then we swap this program from this particularly we swap a program out, that is from memory, and new programs also swap in memory. Means sometimes it is fill up, we just swap in, okay, from memory and swap out from memory. Like this, different concepts are used for this base register addressing mode. And in this case, same case also we can define effective address also. We can write effective address EA. Okay, EA is a effective address. So in this case, what happens? How to define effective address? Effective address is define content of a base address. Okay, content of a base address plus address part of the instruction. Okay, plus address part of instruction. So in this way index address is defined. One is a content of the base address, where the base address is here, and the address of the instruction, defined in memory. So both combination to make a base register address. Okay. So this is the basic concept how to define effective address for base register address. Now we see next is the auto increment addressing mode. Okay. Auto increment addressing mode, once address mode is defined, that is in some, it is actually some special case of register indirect addressing mode. Auto increment, auto decrement are used to access the data in sequence from memory. Okay, to access the data in a sequence memory means where data is available, the sequence either decreasing order or increasing order data can access. Okay, in this case what happens, similarly the operand also can be defined or effective address of operand, we can write also effective address of operand defined through content of register. Okay, effective address of operand defined through content of register. What is the content of register? It will define. Suppose it is go to auto increment. So it is defined the particular address is here like 100. The pointer point to 100. If it is increase, you see the 100 is come to 100 plus 1, 101 or 101. Okay, we come to 101 or 101 like this. It is automatically it is increase. Since content of a register, suppose here 100 point to here 100, again since it is equal to increment its address, it point to 101 or 101. Okay, in this way we can create that particularly auto increment addressing mode. Okay, similarly if we go through auto decrement decrement concept, then similarly address will be decrease according to this auto decrement, like opcode and auto here auto also use for decrement. Here address is here 100 point to 100, decrease means here 100 decrease to 99. Okay, decrease to 99. Actually this increment or decrement defined through that is certain values, that is size, d size you can tell as a size. What is the value we can define? It will depend on the size. That size is defined in a different ways. Very simple way I will show you how the size will decrease. Okay, how the size will be decreased, I will show you. You can understand accordingly. Okay. So how I will define, like that is suppose add, here one example you can take add. Okay, R1 and R2 minus. Okay, R2 minus. In this case what happens, this equation can be defined R1 is equal to R1 minus. Okay, because this is minus memory of R2 defined in this way. Okay, and this particular size also defined through R1 minus D. This size will define. Here memory we see 1 size, actually it is 1 size, increasing, one increase or decreasing, it is minus 1. Okay, so if it minus 1, if D is equal to, if we go through D is equal to 1, so automatically R1 minus 1. Okay, if we go through here, similarly same case suppose we will consider in a auto increment. Okay, if we go through auto increment, then also we can define add R1 R2 plus. Okay, like this, add R1 R2 plus. Okay, then how to define R1, define R1 plus R2. Okay, memory of R2, actually memory of R2. So how to define? Very simply, if this is in this case, okay, then what happens? R1 plus 1, it is increasing order, R1 plus 1. In this way, different ways we can define this address mode. So auto increment or auto decrement, just it depend on that size, d size if that is 2, suppose 2, for example here the address is 300, r1 is 300, for example r1 is 300, d is 2. If we go through this one, then what happens, r1 is equal to 300 plus 2, that is 302. Okay, if we go through same thing, r1 is equal to 300 minus 2, that is 298. Okay, 298. In this way, different ways we can define, that is auto increment or auto decrement. Okay, so whole, that is addressing mode, can be defined in this manner. We discuss, that is 12 addressing mode in a different ways. So you can use different ways with a certain example. Then you can find out how the different address mode, which is with different instructions, or how it is defined, also expressions as per this different diagram, or different that is systems or architecture. Okay, so I hope all of you understand this particular topic, that is a type of addressing mode. Okay, very simple addressing mode, that is 12 types normally we use, maybe more, but 12 types addressing modes are available. So these 12 types I discussed all. So I hope all of you understand these 12 types. This is a very simple way I explained, and different examples also I took and explained all addressing mode with different examples. I hope all of you understand. I think that is you understand all concept of this addressing mode. So thank you very much. Please subscribe my channel and like it. If you want to give some comments, you can give me. Okay, thanks to all.